So today we're going to talk about something really fundamental. It's this deep, deep drive that we all have to find a meaningful signal in a world that's just full of noise. And it turns out this is one of the most essential traits there is, not just for us, but for the machines we're building to think like us.
I mean, that sounds like a totally random list, doesn't it? What on earth could possibly connect hearing a phantom voice in a fan, getting completely lost in a good book, and, the super high-tech world of training an AI to use a smartphone?
Well, believe it or not, the answer to all three is basically the same. It all comes down to this one, single, incredibly powerful idea. It's a core feature of how any smart system, whether it's made of cells or circuits, tries to make sense of all the chaos out there. So let's start with the one that's, well, a little bit spooky.
We're going to kick things off with a phenomenon you've probably experienced yourself. Something a little weird, a little unsettling, what you might call the ghost in the machine.
Seriously, think about it. You're lying in bed, it's quiet, and the hum from the air conditioner suddenly sounds like words, like a faint radio station, or maybe the sound of the shower starts to sound like a little piece of music. If you're nodding along right now, don't worry, you're not going crazy. You're perfectly normal.
Yeah, there's actually a name for this. It's called auditory pareidolia. Now, the key thing to get here is that it's a sensory illusion, not a hallucination. A hallucination is when your brain makes up a sound out of thin air. Pareidolia is different. It needs a real sound source, that fan, that static, that running water, that your brain then grabs onto and tries to shape into something that it recognizes.
Okay, so why do our brains do this? This chart breaks it down perfectly. Imagine you're one of our ancient ancestors. You hear a rustle in the bushes. It could be a tiger, or it could just be the wind. Now look at the options. If you think, it's just noise, but it's actually a tiger, that's a miss. Your lunch. Game over. But if you think, whoa, that's a tiger, and it's just the wind, that's a false alarm. That's pareidolia. The only cost is you jumped and maybe felt a little silly. Evolution is a numbers game, and it will always favor the brain that makes 1,000 false alarms over the brain that makes one fatal mistake. We are literally built to be jumpy.
So you see, this isn't just some weird quirk. It's the direct output of a very, very sophisticated system. Let's dig into how your brain actually pulls it off.
This quote absolutely nails it. Your brain doesn't just sit around like a microphone passively recording whatever happens. No way. It's constantly running simulations, building little models of the world, and making predictions about what it expects to hear and see next. What we call perception is really just the process of updating those predictions when they're wrong.
And what's the number one thing your brain is trying to predict? Agents. People, animals, anything with a mind of its own. This bias is so strong that scientists have a great name for it. The Hyperactive Agency Detection Device, or HAD. Basically, when faced with any fuzzy, ambiguous data, your brain's default setting is to ask, who did that? So, hearing a voice in the static? That's not a bug. It's a core feature of your survival software.
Okay, so we have this basic survival instinct, but how in the world does that get us from hearing things in the dark to creating something like, say, an epic novel or a beautiful painting? Well, this is where it gets really fascinating.
Just look at this comparison. It's basically the same playbook. The part of your brain that looks for agency and random noise, well, that's the same impulse a storyteller uses to create characters. Your brain connecting random sounds to make a word, that's a writer connecting plot points to make a story. Your brain filling in the gaps to make sense of a muffled sound, that's a great book relying on your imagination to build its world. It's the same machine doing the same job.
We love this pattern-seeking stuff so much, we've even turned it into a formal artistic technique. The classic story within a story is a perfect example. We're literally nesting patterns inside of other patterns, creating all these cool, complex layers of meaning. It's our brain's favorite game, but turned into art.
And this isn't some fancy new trick, it's as old as stories themselves. In the Odyssey, a huge chunk of the epic is just Odysseus telling you his own story. In the Canterbury Tales, the whole point is that it's a collection of stories being told by the characters. And, of course, The Princess Bride. It's a story being read by a grandpa to his grandson. We are just obsessed with these layers.
And this idea is firing on all cylinders in modern literature, too. Take this quote from the novel Lanny. It's about this young boy who's basically a human version of this whole concept. He's this incredible empath who just soaks up all the voices, the gossip, the secret thoughts of everyone in his village, until he becomes this living chorus of signals that he's pulled out of the noise. And it's not just for art. We use this same exact skill for data analysis. I mean, think about it. There are thousands of poetry journals out there. It's total noise. So how do you find the best ones? You look for a signal. In this case, someone counted up how many times each one appeared in the Best American Poetry Anthology. We take this giant, messy pile of data, and we impose a pattern on it to find something we think is meaningful.
Which brings us right up to today, to the most powerful and maybe the most profound version of this ancient human drive. Because now, we are building machines in our own image, and we are teaching them to do the very same thing our brains have been doing for millions of years.
And that's the whole game for a huge chunk of modern AI. The challenge is the same one our brains face every single second. How do you look at an explosion of chaotic data, like the millions of raw pixels on a phone screen, and pull out the one single meaningful signal you need, like the one button to press?
Let's take an AI built to use a phone. Its process, when you break it down, is a dead ringer for our predictive brain. First, it takes in the noisy input, all those raw pixels. Then, it processes that mess, comparing it to its memories of what's worked before to predict the best next move. Third, it sends out a clean signal, a click here, a scroll there. And finally, it stores the result of that action, which makes its next prediction even better. It's a feedback loop that gets smarter with every single cycle.
Or check out this brilliant project, Aural State. It basically does what our brain does with fan noise, but on purpose. It takes all this invisible, chaotic server data, like CPU load or memory usage, and deliberately turns it into a structured, useful sound. So a rising, high-pitched whine might tell a developer the CPU is about to overheat. It's a sonic debugger, a true ghost in the machine that we built intentionally to help us.
So where does this all leave us? From the dawn of evolution to the highest forms of art, and now into the age of artificial intelligence, this one single thread connects everything.
Think about it. Whether it's your brain finding a ghost in the static, a novelist nesting stories inside of stories to create some deeper meaning, or an AI figuring out which tiny icon to tap on a screen, the fundamental principle is exactly the same. It is the timeless act of imposing order on chaos, of turning noise into signal.
And that leaves us with one final and pretty massive question. Our own pattern-finding software, our brains, was fine-tuned over millions of years for one main reason: to survive, to find food, avoid predators, and find a mate. But now, we're building these artificial minds and pointing them at a universe of information we can't even comprehend. What signals, what patterns will they eventually decide are the most important? And what happens when they do?